Data is something we're bombarded with every day. How that data is collected and how that data is displayed can affect how we interpret the data. So what we're going to look at right now is some things to watch out for to make sure that when data is collected, it's collected in a way that gives us valid results that are interpreted fairly. Students begin studying statistics and probability in 6th grade. They have to look at how to gather data, how to describe data, how to display data, and how to interpret the data. Now we'll look at ways to describe and display and interpret data a little bit later on, but right now we're going to focus on gathering data. So when data is gathered, we want to make sure that the questions that we're asking when we gather that data are statistical questions. To be a statistical question, a question has to expect that the answers to that question will vary. And we have to have a way to collect those varying answers. So the question, how old are the students in my school, would be considered a statistical question. Certainly the ages of the students in my school would vary, and it's something that I can record and account for. A question like, how old am I, is not a statistical question because there's no variability in the answer. I am just one age. My age doesn't vary. Data is gathered about a population. So for example, our population could be the marbles in a jar, and maybe we want to know something about the colors of the marbles. Well, to do that, we'd want to look for a simple random sample of the marbles. A simple random sample is a subset of a population, so a certain number of marbles chosen from the jar could be a simple random sample. And a simple random sample has to have the same likelihood of being the sample as any other sample of the same size. So one way to think of that is that when we have a simple random sample, it has to be representative of what's in the entire jar of marbles. So suppose this is a sample of 10 marbles we chose from the jar. That looks pretty much like all the marbles in the jar look. So that would be a good example of a simple random sample. If these were the 10 marbles we pulled out of the jar, they may not be a good representation of what's in the jar because it looks a lot different than what we have in the jar. On the other hand, it might just be exactly what we pulled out of the jar when we pulled 10 marbles randomly from the jar. If we got that sample on the right every time we tried to pull marbles from the jar, we could suspect that that was not a representative sample. Suppose you're in charge of a production line, and you'd like to know if the product that you're making has an unusual number of defects. So you decide to take some random samples of the product line. What if you decided to test the first 10 items that were produced every day? Would that be considered a random sample? Well, probably not. After all, the first 10 items produced each day might be perfect because your workers are refreshed and they've just come to work and they're not making any mistakes in producing the product. Or maybe the first 10 items have a lot of defects because when your workers come to work, they're a little bit tired, they've just woken up, and they make a few mistakes at the beginning that they don't make at the end. So we would say that this sample is not a representative sample of the population. What if you decided to test every 100th item that was produced? Would that be a random sample? Well, likely it is a random sample because you're selecting items at the beginning of the shift, in the middle of the shift, and the end of the shift. So you're looking at distributing the chances that you've got defects throughout the day, so that has a better chance of being a random sample. Now, when we ask questions in a survey, sometimes those questions can be biased, and we have to be careful of that and try to eliminate bias from survey questions. Biased questions are worded so that the answers that people give are skewed. They're affected by the way we ask the question. When Donald Trump was approaching his 100th day in office, news organizations were surveying people to see what they thought about the job he had done so far. These are two of the survey questions that were asked from two different surveys. Think about whether the questions are biased, whether they could affect the answers people were giving. The first question is, if you had to choose between reforming the tax system and fixing the healthcare system, which would you say should be given a higher priority? Well, that could be a biased question because it's implying that there are two high priority things, fixing the tax system and fixing the healthcare system. And perhaps the person being asked thinks that there's another high priority thing and those two are not high priority, but they're still being asked to choose between those two things. So perhaps that's a biased question. The other question is, so far, would you say Donald Trump has had the right priorities or that he hasn't paid enough attention to the country's most important problems? Well, that could be a biased question as well. The first part of it probably isn't biased. Would you say Donald Trump has had the right priorities? But the second part of that question could bring in some bias. He hasn't paid enough attention to the country's most important problems. That seems to imply that maybe he hasn't paid attention. So perhaps if that question had been asked in this way, would you say Donald Trump has had the right priorities, or would you say he has had the wrong priorities? That just kind of gives people an either-or answer, and it's not implying anything about whether he has paid attention to important problems. Now, we said that statistics and probability are first introduced in the 6th grade, but the ideas that are first developed in 6th grade are actually carried all the way through high school. So if you take a look at these standards for high school statistics and probability, you're going to notice a lot of the same topics that you saw in 6th grade. For example, understanding statistics as a process based on a random sample. Recognize that there could be different answers based on the biases in the questions of the survey. So you can see that the ideas that are first introduced in 6th grade are continued and built upon all the way through high school.